Hello, my name's Leyi from North China Electric Power University. I'm very glad to attend the conference and give an academic report here. My paper title is Applying Optimized Preprocessing Technique and Extreme Learning Machine for Hybrid Wind Speed Forecasting System. I will propose a hybrid forecasting system for wind speed and demonstrate the effectiveness of the method through experiments. My report is divided into 4 parts. The first part is introduction. I will introduce the research background and research significance of this paper. After the Industrial Revolution, a lot of air pollution caused the environment to worsen. Global warming and the frequent occurrence of extreme climate have endangered the living environment of human beings. Therefore, carbon reduction work is urgent. In order to reduce carbon emissions, we are facing these challenges. First, with the development of science and technology, human demand for energy is still growing, and the traditional primary energy may no longer meet the energy demand. Second, the proportion of high energy consuming industries is high, and the structure of heavy industry is facing the challenge of changing the development path. Finally, the high carbon energy structure have a large scale. Transforming the energy structure to a carbon-free direction is an important way to reduce carbon emissions. To reduce carbon emissions, we can make the following efforts. In terms of energy production, primary energy is transformed from traditional coal resources into clean energy. For energy consumption, electrification is the main direction. At the same time, it is necessary to promote energy technology innovation and industry transformation, and provide stronger technical support for the transformation of energy structure. Seeking a green and low-carbon development route have become an important issue for us to discuss now. In countries around the world, large-scale renewable energy bases have been established, and wind power has been the main energy generation. The figure on the right shows that average renewable capacity additions and the cumulative installed capacity. Both the total installed capacity and the growth rate of wind power have increased year by year. And according to the IEA forecast, the development momentum of renewable energy installed capacity is still rapid. Wind energy is one of the most potential renewable energy sources. Its characteristics pose a certain threat to grid connection. For the wind farm side, wind speed forecasting and wind power forecasting can effectively solve the problems of wind curtailment, high operating cost. For the grid side, it can provide a basis for the power generation plan of the power sector, while improving the wind power consumption rate and reduce the cost of power generation. Therefore, accurate wind speed prediction is crucial. Research on wind speed prediction can generally be divided into these directions: physics models, mainly include numerical weather forecasting systems, which use external environmental factors to predict changes in wind speed. The statistic model mainly uses traditional statistic methods to fit and predict the wind speed. Neural network is widely used in wind speed prediction due to its good training factors. Nowadays, in order to better improve the prediction accuracy, a hybrid model combining multiple models is used to predict the wind speed. This paper proposes a hybrid wind speed prediction scheme, including data preprocessing, machine learning, model optimization, and error correction to achieve the purpose of effectively predicting wind speed. In this part, I will describe the main method used in this paper. In the data preprocessing, variational mode decomposition method optimized by envelope entropy is introduced. The envelope entropy is derived from the envelope spectrum, which reflects the complex of the signal. A smaller entropy value means that the sequence contains more feature information and less noise. Wind, as a form of energy, applies to entropy theory. VMD is an adaptive data decomposition method by solving the variational problems. The noise stationarity of signal is reduced by decomposing several intrinsic mode functions. The choice of VMD model number and the penalty factor is related to the effect of decomposition. This flowchart shows the specific flow of the improved VMD method. By calculating the average envelope entropy of different model decomposition numbers, when the average envelope entropy is the smallest, the corresponding K is the optimal model number, and the same method can also determine the optimal penalty factor. Extreme learning machine is used to build the main predictive model. The put weights and hidden biases are randomly generated. The BIT algorithm is used to determine ELM's optimal weights and biases to optimize model structure. Inspired by the ultrasonic of bits in nature, the BIT algorithm was proposed as a swarm intelligence search algorithm, which is widely used in various optimization theories. The BIT algorithm regards the individual position of each bit as the solution of the problem. The optimization process is two stages: the global search stage and the local search stage. In the first stage, individual bits enter the optimal solution candidate region by updating their positions. In the second stage, the pulse frequency and the sound loudness of each individual bit are adjusted to achieve the purpose of fine search, and a new optimal solution is generated through comparison. In addition to the IMF, the VMD also includes a residual sequence that cannot be decomposed, and the residual sequence is a random sequence fluctuating around zero. The kernel density is estimated for the residual sequence, and its probability distribution function is obtained. Then, the criteria of probability distribution are randomly sampled. Finally, the value corresponding to the quantile is obtained according to the residue distribution function, which is the predicted value of the obtained residue. This figure shows the main process framework of the model in this paper. Step 1. Based on the minimum average available entropy, the optimal VMD parameters are selected in turn and obtain IMFs and a residual sequence. Step 2. Establish a BAELM model for each series obtained by VMD and output the prediction results of each component. Step 3. For the residual era after decomposition, the KDE is used to fit the probability distribution of the residue. Then, residual prediction value is obtained. Step 4. The predict value of IMFs and the residue predicted value are added to obtain the point forecasting results of wind speed. In order to verify the effectiveness of the method in this paper selects the data of 2 wind farms for verification. For the convenience to display, I select one wind farm to display the results in this presentation. This figure shows sequence of wind speed at the Saltwind wind farm in Spain. 1,000 data was selected, which fully reflect the uncertainty of wind speed. Divide the first 800 data points into the training site and the last 200 points into the test site. In order to verify the prediction accuracy of the model, the figure compares 4 classic neural networks of ELM, BP, LMAN, and LSTM. The comparison result 1 shows that the prediction effect of a single neural network model is not good and has a large degree of lag. The model proposed in this paper effectively solves this problem. In order to further prove the effectiveness of the model proposed in this paper, the comparison result 2 shows the effectiveness of model improvement. Compared with the single ELM model, the prediction results of the hybrid model are more suitable for the original sequence. This shows that the improvement of the decomposition method and the neural network model is helpful to improve the prediction accuracy. For the purpose of evaluating the model forecasting effect more comprehensively, the mean absolute error, mean square error, and the mean absolute percentage error are used to evaluate the prediction accuracy of the model. The calculation results are shown in this table. According to the above table and picture, it can be seen that error indicators of the proposed model have decreased compared with other models. This part is the final conclusion of this paper. This paper proposes a hybrid model system for ultra short-term wind speed forecasting, including series decomposition, intelligence algorithm model, and error correction. The prediction consequence of the combined model is better than that of a single neural network, especially the data decomposed by VMD can greatly improve the prediction accuracy. Besides, compared with the unoptimized model, proposed model have a certain degree of accuracy improvement. Moreover, the effect of the model is further improved after error sequence prediction. The experiment results show that compared with other neural network models, the prediction results of the proposed model are more in line with the initial one-speed series. At the same time, the error matrix has decreased significantly, and the prediction accuracy has been improved greatly. In conclusion, the model proposed in this paper has achieved satisfactory results and provide a technical basis for the operation of the wind farm. That's my presentation. Thank you.